In this video, we're going to prove the uniqueness theorem. So we've seen this theorem in the past, and we've seen in one of the early videos we've seen this example here. So when you try and find the antiderivative of this, it will give you this, or it will give you this. But the uniqueness theorem states that the two are actually the same, but only differ by a constant. And I forgot to show you this. So when you get one, take away the other, it will give you a constant. So let's just get, or you can get this, take away this, it will also give you a constant. But for the sake of this video, let's just say this, take away this. So now we're going to get this, which will be this here, take away this, which is this bit here. Okay, and then tidy up, it will give you this here, and then you can merge this block with this block here. So merging those two blocks would give you this, and this whole thing here is equal to 1. Okay, and then when you look at this here, you've got a constant here, which is this bit here. Take away another constant here. So you've got a constant that you don't really care about. Take away another constant which you don't really care about. When you can merge the two together to give you a new constant, and this new constant we don't really care about either. So let's just call it C3. Now, when you are here, this C3 here is a constant that you don't really care about, and here you've got a number. So let's merge the two together. It will give you a constant. It will give you a constant that you don't really care about. So let's just call it C4. Okay. So what I'm trying to show you here is that when you get, what I'm trying to show you is that when you get this, take away this, it will just give you a constant. It will give you a constant. So there. Yeah, so now we're going to prove it. So what the theorem is saying is that if f prime of x equals g prime of x, so what this statement here is saying is that if you have a function, let's just say you've got a function which looks something like this, f of x, and then you've got another function, g of x. Now what this statement here is saying is that if the derivative of this here, let's say the derivative of this happens to be this graph here. I know it's a bit unrealistic, but let's just say the derivative of this line here happens to be like this. Okay, and what this statement here is saying that if the derivative of g is also the exact same derivative, also happens to be the same. So what it's saying is that the derivative of this g here is also this exact same derivative here. So basically, they have the two functions here have the same derivative. That's what this statement here is saying. The derivative of the two functions are exactly the same. That's what this statement here is saying. Now, if the derivative of the two functions are exactly the same, then so hang on. Looking at this statement here, then this take away this must equal 0 because so here this line here represents a derivative of this, and it also happens to be the same derivative as g here. Now if you get so this line here represents f prime of x, and then this line here also represents g prime. Now if you get this exact same line, take away the exact same line, then you're going to get 0. So that's what this statement here is saying. If you get the exact same line, take away the exact same line, then everywhere it would be 0 everywhere. Okay, so hang on. So what this statement here is saying is that if you get this line, take away the exact same line, your graph will look like this. So f prime so this graph here will look like this. It will look like this. Bear with me. It will look like this. That's what it will look like. Okay. So now consider a new function, h prime of x. Okay. Let's just say h prime of x. Let's just say h prime of x. Hang on. Let's just say h prime of x equals. Remember, we are defining this to be the same as this thing here. To be the same as this thing here. Okay, so hang on. So f prime of x, take away g prime of x, it will be 0 everywhere. And now we're saying let's just invent a new function to be this line here. Now if this function here is always equal, then h then the antiderivative of this must be a constant. Must be a constant. So if you've got f prime of h equals 0, then the original f must be a constant. Must be a constant here, or it could be up here. It doesn't matter. Or it could be down here. It will be a constant because when given this here, if you differentiate this, it will give you 0. Okay, it will be 0 everywhere. Now, if this here is exactly the same as this thing here, then you can say that, well, hang on. So currently h prime of x equals 0. Then that means h of x equals a constant. Okay, so from here you can jump up to here. So now looking at this here, from here you can also say, you can jump up to here and say that f, the original function, take away the original function of g, must be a constant. So if this here is true, then you can say that f of x, well, add g of x to both sides, so that will be g of x must be a constant. Okay, and the reason why you can jump, so when you're here, if something equals 0, then it means that when you find the antiderivative, it must be a constant. You can accept this, I hope. Well, you have to accept this. That means you can jump from here, you can jump to here. And the reason why you can jump from here is because suppose I were to give you this. Let's just say this block here is 2x to the power 3, and then this block here is let's say 5x squared here. You see, from here you're happy to be able to jump to here because this block here will be 6x. The point here is that you can separate the two. You can separate the two and do it individually. The point here is that the reason why you can jump from here to up here. Well, you can jump from here to up here. Okay, because you can consider these to be separate. You can consider these to be separate. So when given this here, you can jump from here to here. Basically, that when given this here, you can do this separately from this block here. You can do it separately. So therefore, when given this here, you can actually jump back up to here. So hang on, it's a bit messy. Sorry. The point here is that when f prime of x, take away g prime of x equals 0, then you can jump up here and say, oh, f of x minus g of x equals a constant. You can jump from here to here. You can treat these. You can treat this to be separate from this here. So this block here you can jump to here, and then this block here you can actually jump to here. It's like me giving you this block here, and then when I ask you to differentiate the combination of the two here, you can just do it separately. So it's the same, but just working in reverse. Okay, I hope you understand.